Today we're going to go over imaginary numbers. And imaginary numbers are something you may not have seen before. And this is a little difficult, so you may have to watch the video more than once to really absorb what we're going to talk about. So, what is I? Well, I is not a variable. It's not an X and a Y or an A and B. It has meaning. It means the imaginary unit, and it was actually developed by mathematicians. As our technology gets more and more complicated and we start designing things, we keep running into this square root of a negative number that's impossible. It's not, we can't finish our design, so we have to figure out ways to get rid of it. So I, by definition, is the square root of -1, and it's going to help us with our designs as engineers design something to get back out of the imaginary world. You can't design a bridge and beams, you can't design the flow of fluids, and you can't, well, our cell phone won't work, because all of those, as you design, hits that square root of a negative number, and you have to figure out how to get rid of it. And so to do that, to keep working, we came up with a definition. So the definition of I means square root of -1. So anytime we see the square root of -1, we can replace it with an I. Now, if we were doing square root of 4, the reason square root of 4's answer is 2 is because there were 2 of something. There was a 2 and a 2 that made the 4. So the answer to square root of 4 is 2 because there were 2 of something. But no matter how hard you try, you're never going to find something, 2 numbers to multiply together to get -1. It just is impossible, which goes back to this is imaginary math and we need a way to represent it. So let's decide how this might look. What if we have the square root of -100? Well, we know from radicals that we need to factor. So let's factor and try to come up with 2 numbers that are exactly the same. Well, if I tried -10 times -10, well, that won't work because that gives me +100. And if I try 10 times 10, I still get +100. There's no way I can do 2 numbers exactly alike and get 100. That's why this is imaginary. So what we're going to do is we're going to use our radical rules, and we're going to break this down to 10 times 10 times -100. And that gives us -100. But we notice that there's 2 10s. Well, if there's 2 of them, and we're doing square root, because we can pull out those 2 if it's an index of 2, then we can pull out the 10 and put it in the front, and all we have left is the square root of -1. Now the square root of -1 is a definition though, and the definition of the square root of -1 is I. So what we really have is a answer that is 10i. 10i, because the square root of -1 is defined as I. So let's try a few of these. We have square root of -4. What did you think the square root of 4 is? Well, the square root of 4 is 2, isn't it? So let's see if we can't use that to our benefit. 2 times 2 times -1, that gives me -4. I have 2 of something, so I can pull those out. And all I'm left with is the square root of -1. But what is the definition of I? The square root of -1 is I. So I had 2i. So the square root of -4, and 2 popped into your head, but it's just an imaginary 2. It's 2i. Well, let's look at 81. I know that 9 and 9 popped into your head. We have 2 9s, so we can pull it out front, and we're left with the square root of -1. But the square root of negative 1 by definition is I. Are you beginning to see? Now we have 50, and when we looked at 50, we didn't see a square root, so we were a little confused there for a minute, and then we remembered, oh yeah, this is 25 times 2, and 25 is a square root. So 5 times 5 times 2, and there's our negative 1. We have 2 of something, so we pull out the 5, and now we have square root of negative 1 and 2. Well, there's just not a whole lot we can do with the square root of 2. It's just going to be stuck there. But the square root of negative 1 is I. So you need to stop the video and do 1 through 4 and see if you can't use your I definition. All right, now that we're back, why would you ever have square root of negative 100? Well, let's do a little quickie here. What if we had x squared plus 100 equals 0? That doesn't look too bad, does it? Some engineer's working, and this is what he gets. But when we move the 100 to the other side, it becomes negative, doesn't it? So now I have x squared equals negative 100, and to solve for x, I have to take the square root of both sides. And when I take the square root of both sides, I end up with x equals, there it is, square root of negative 100. And we already know that that is 10i. So stop the video and do your number 5. Now we're going to talk about the powers of I and how they affect everything. So we know the definition of I, and I is equal to square root of negative 1. Then what would I squared be? Well, I squared means I times I, which would be square root of negative 1 times square root of negative 1, wouldn't it? And our radical rules tell us that since they have the same index, we can put them together. Did you notice something? Look, there's 2 of them. And if there's 2 of them, we can pull them out. And now you have negative 1 on the outside, and nothing was left, so I don't need the radical. So we have a new helpful definition. I squared is equal to negative 1. Well, why would we need that? Why would that be so important? Well, let's look right here. I have 3i times 2i. I'm some engineer, I'm doing something, I have 3i times 2i. Well, I'm going to move it around a little bit because I can do that in commutative property of multiplication. And you need to remember, 3i means 3 times I. Don't forget, that's a basic rule of algebra. So 3 times 2 is 6, and I times I is I squared. But what do we know about I squared? Well, I squared is negative 1 by definition, so what we need to do is a last step. This is 6 times negative 1, which gives you negative 6. Now, why is this so important? Look, we were in imaginary world, and remember, we don't want to drive across a bridge that's in imaginary world. So if we don't want to drive across a bridge in imaginary world, we need to change into the real world, and that's exactly what happened right here. They went from the imaginary world to the real world. Let's look at some of the others. I to the third, I to the fourth, I to the fifth. Well, if we use our exponent rules, we realize that I to the third is really I squared times I. And we know that I squared is negative 1, so this is negative I. We're not getting any other numbers. We just keep getting these I things, don't we? Let's try I4. I to the fourth is I squared times I squared. We know that. And we know that I squared is negative 1. So really what we have is negative 1 times negative 1, which is equal to positive 1. So we have I to the fourth equals 1. We have another one. Then what about I to the fifth? Let's use our rules. I to the 5th can be I to the 4th times I. There's 4 of them, and another one is 5. But what is I to the 4th? Well, that's just 1. So 1 times I is I? Does it seem like we just kind of started over? I don't know. Let's think about that. So we have 4 things that we know. I, -1, -I, and 1. Those are the only answers we've gotten. The whole day, everything we've done, those are the only 4 answers that we've gotten. Let's try 26. Out of the 26. If we broke that down into 4 and 4 and 4 and 4 and 4 and 4 into 2. If we add all those up, you can do that with your calculator if you want, it adds up to 26, doesn't it? And we know that I to the 4th is just ones, so this is 1 times 1 times 1 times 1 times 1. And we know I squared is -1, so I to the 26th is equal to -1. We're still only getting those kind of answers. You know what's happening? We're going in a circle. This is one of your first cyclic expressions that you're going to see. There's going to be more of them along the way. But for once, we're going to look at it and we're going to realize that this is just going in a circle. Well, let's look. I to the 0, which anything to the 0 is 1. I to the 1st, well, anything to the 1st is just itself. I squared is equal to -1. We determined that. I to the 3rd is equal to I. And look at that. I to the 4th is equal to 1. We started over. We're going in a circle. What did we say I to the 5th was? We said I to the 5th was I. We're going in a circle. There are only 4 answers, and we're going in a circle. So let's try I to the 7th. Let's start right here. This is 0. Right at 0, we go 1, 2, 3, 4, 5, 6, 7. So I to the 7th would be -I. Let's try I to the 8th. Now something should jump in your head, but let's go ahead and start. Start at 0. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8. I to the 8th is going to equal 1. You know what I'm beginning to think? I'm beginning to think anything that's a multiple of 4 is going to equal 1. I to the 4th equals 1. I to the 8th equals 1. What do you think I to the 12th would equal? 1, because that's a multiple of 4. What is I to the 16th going to equal? 1, because that's a multiple of 4. So we only have 4 answers that we can get, and we're going to use these to try to help us stay in the real world. That's how we're going to use them. We're going to stop there. I know there's more on your note sheet, but we're going to stop there. That's a lot of information. Finish the practice problems you need to try, and we'll go into the rest of complex numbers in the next video.